Just pay attention now. Last week we talked about the heat transfer, different form of matter as we talk about. If you remember that we talk about conduction and how the matter simply, or how the heat transfer in a solid matter. I need to emphasize on the following. We take that the rate of heat transfer Q over delta T or delta Q over is equal, if you remember that, K, then we say that is A over L times delta T. I want to say something before, because I need this one. You should notice the following, Yeshua. K is a constant, right?
Yeah. Yeah.
And we know that that constant is called conductivity of a material. So this is something characterizes the material. When I say characteristic, it's something always constant. Now we have something else to talk about. What we recognize that Q over delta T is direct proportion to the area. You should notice like this. And the Q over delta T is inverse proportion to the L. Okay, and finally, Q over delta T is direct proportion to the temperature difference. Please, you have to read this, Yeshua. I'm going to ask you that just like these questions. You will see a part of these questions. No one will ask you, what is the relationship between delta Q and K? We know that K is constant, doesn't change. But we should know that thing. So in this case, if I double the area, rate of heat transfer will double. If I double the length, rate of heat transfer will half. And if the actually the temperature difference changes, also this changes. Please, you have to know how to read. I need this idea, Shba. You should know how to read the formula that you have. Okay. We talk about the conduction. We said that conduction always occurs in solids. Where there's a condition should be satisfied. What that condition?
Physical.
Yes, Muhammad. There must be physical contact between the objects. There will be nothing actually, if there is no physical contact, no by influence, nothing actually further apart will be any transfer. In the second case, we talk about convection. Right, Shabab? Convection mainly occurs in fluids. Can you explain it for us how it occurs in fluids, Shabab? Well, how the criteria, how it works? Yes?
Because there is a difference in density, so the water will be less
dense, yeah.
less dense, so it will
rise up.
Rise up. And the cold will carry the higher water.
Yeah, that's what. Always, we found that the density changes with temperature. So simply, you can say, if we have two different fluids with different densities, because they have different temperatures, always we say that the hotter one, which is the less dense, or the lightest, here in this case, it will rise up. And the colder one, which is more dense, it will sink down. Right, ya Shabab? Right. Okay, Rabbi. Now we stop, I think, here. I'm sorry, this is Wallah Shabab. I try to make it, doesn't work. I will try to give you a PowerPoint presentation for it. Okay. If you have a quick time player at home, you can do it. Now we talk about the third type, which is radiation. I want to say something. Radiation consists of electromagnetic waves. When I say electromagnetic waves, there is a large spectrum of electromagnetic waves. Did you know that? Did you know that light is a part of it, the visible light? And for example, microwaves is electromagnetic waves. The sound here we have also Shabab, as an example, radio channels or radio wave is a microwave. Ultraviolet, infrared, a lot of things. There is something I need to tell you something about. Yes, Shabab, you know that visible light. You studied thing, I think this in school. Here, it's actually Roy G. Bev. You know, remember red, orange, yellow, green, blue, indigo, right? This is the visible light. Now, we start from red, right?
Yes.
We have beneath the red, what we call it? تحت الحمراء. Infrared. We start from red. So we have يا شباب here, the first one is called IR. IR, that means it's below here. Now, this is V, stands for violet. What we have above the violet? Ultraviolet, UV. Okay, شباب? So it's easy to memorize this now. Now, we have IR here, infrared. Then we have microwaves. Then we have radio waves. Radio. Now, on the other side, we have X-rays and gamma rays. I'm 100% sure that you studied this before. صح يا شباب? The whole of it, it's called by electromagnetic spectrum. الطيف الكهرومغناطيسي. All these يا شباب, they have a speed of light. All of them, which is 3 times 10 to the power 8 meters per second. All of them. So, if I say any one of them produce heat, yes, we can say ultraviolet. It's produced some heat sometimes. Yes, it is here. It's a kind of radiation. If we have infrared, it's a kind also of radiation. Microwaves, just like that. Okay, Shabab? All of them. So, anything related to electromagnetic waves, we call by heat transfer by radiation. We found that the following. Follow me. The rate of heat transfer by radiation equals E sigma A T to the power 4. I will explain each of them. First of all, E, this is called emissivity. In Arabic, we call it يا شباب نفاذية الوسط. Sometimes, يا شباب, every type of material has different emissivity than the other one. Let me say something. We know that white cloth reflects most of the light, right? Yes. While the dark cloth absorb the light. So they have different emissivity. نفاذيتهم متغيرة يا شباب. This makes the light, when the light falls in this, it makes the white one reflect most of it. While the dark colors, it's absorbed most of it. That's why we have, in summer season, hot season, we wear always a light cloth, and in cold season, we wear actually the dark cloth, right? This is an idea. And this is, by the way, is constant. Second thing, you should know something, that sigma is a constant called by Stephen Boltzmann constant. It has a word, it's 5.67 times 10 to number. It's another constant, this one. Now you will see that. It is mentioned here, Shabab. It's Stephen Boltzmann constant. How much is it? 5.67 times 10 to the power negative 8. Okay, Barakallah. So, E is constant and sigma is constant. What is left?
Area.
A and T to the power. See, A is the area and T is the temperature. Not the temperature difference. A is temperature. I'm going to say something here. From this formula, we should notice the following, Shabab. That the rate of heat transfer by radiation depends on area and the fourth power of temperature, not T only. That's why I will say Q Shabab هنا over delta T is direct proportional to the area. Yes, area exposure to the heat. يا شباب انتم لما الان تكون تحت اشعة الشمس ما تضع ايدك او حاول تبتعد عن الشمس صح؟ You try to minimize the area. صح؟ This is what happened. You try to minimize the area by exposing the area. This is what happened. طيب, one more thing. We have also Q over delta T is direct proportional to the fourth power of temperature. Oh, fourth power? Yes. That's mean, Shabab. If we double the temperature, Q over delta T will increase by 60. Allah yahfid. Right. If we say, Shabab, if you double the temperature here, you write 2T to the power what? 4. 2 to the power 4, how much is it? 16. Right? So this will increase by what? By 16. It's simple. So you say 2 times 2 to the power 4, which is 16. So please, put this in your mind. if you double the temperature in this case, because if you say whether the heat here, rate of heat transfer, is directly proportional to the temperature only? No. To what? To the 4th power of temperature. Right? You got the point. هي يا شباب تتناسب مع ايش؟ درجة حرارة مرفوعة للأس 4. مش درجة حرارة فقط. واضح بارك الله فيكم؟ طيب. Now I have something on. Emissivity, actually emissivity, we say يا شباب, is something constant. It has a range from 0 to 1. This is always given. And you see that this is unitless or dimensionless, has no unit in it. So you don't have to find it. Now, for example, it's mentioned here, a human skin is very effective radiator at body temperature with E equal 0.97. That depends on the color of the skin. Because most of the people, they have dark color skin. They have different emissivity than the light.
No.
Please stop talking, يا شباب. Now, is that clear for you, شباب? All the details in the formula. I want to say something. Look this easy. يا شباب, we have only 2 formulas in this chapter. One about the rate of heat transfer by convection, the first one, and this one. So 100% there would be a problem in one of them in the exam. This would be sure in that one. Okay. Now let us continue. That's clear for you. One more point. If someone asks you, what is the unit of Stegen-Boltzmann constant? طلب منا يا شباب unit of sigma. Can we find this one?
Yes.
Of course.
Yes.
This is a suggestion for you, but you should be able to do it all by yourself. Make sigma, first of all, this has no unit. Skip it. It's موجود. It's just only number, right? Make sigma the subject that we have it. Sigma is equal to Q over delta T first, right? Over what? A times T to the power 4. So it is what? For this one, you remember this?
Yes.
Over meter square, degree Kelvin to the power
4.
So it is here, watt meter square Kelvin. You Shabab, you don't have to memorize this. You should know how to simply to find it. Okay? I'm gonna ask you this. Wallahi, this is my habit. I like always to ask about the units. It's easy. You have an alternatives. You can say watt meter square over K to the power 4. It will look like the same. So if you're able to find it from the formula, this formula will be given in the formula sheet. That's it. You can answer the question easily. If you have a problem, mathematical problem, this for you will be a problem. Okay, Barbara. Now, let's see the formula. Now we have a modification to our formula. See, in the first formula, we say that Q over delta T is equal to E sigma A T to the power 4. We are talking about radiated energy. In this chapter, in this formula, we are not concerned about the surrounding temperature. Because is that affect? Yes. If I'm in a cold climate, I will radiate more. I will lose more heat. Because there will be larger temperature difference, right? If for example, if I'm in a moderate climate, جو معتدل, I will lose less. يعني احنا يا شباب ليش بنلبس الملابس الشتوية بالشتاء؟ حتى تمنع تحديدا مش عشان التقيق من البرد، هي طبعا التقيق من البرد. حتى تمنع ايش فقدان جسمك لايش؟ طيب ليش ما نلبسها في الصيف؟
نحن نطرد الحرارة.
الناس ما بنفقد هذا المقدار الهائل، صح؟ بالشتاء راح نفقده. You got the point يا شباب. So this is about the radiated energy يا شباب here without considering the surrounding. بدون ما نعتبر ايش الجو المحيط عندنا. If we consider the surrounding, we add this on. See, for an object at temperature T surrounded by environment of temperature T0, T0, the net rate at which the object here radiates is the radiation emitted minus radiation absorbed. Who's emitted? Myself. I'm emitting. Who absorbed? The surrounding, the air or whatever is it. Okay? So this will be the same, just we add T to the power 4 minus T naught to the. This is for the object. See, you get this one. And this is for the surrounding. الجو المحيط فيك, or what is actually surrounding you. Now there will be a question I'm going to ask you. This is not a new law, it's the same as the first one. But here we concern about how much energy retained by a particular object, regardless of its environment. إذا ما أعطاك يا شباب حرارة الجو المحيط, يعني معنى ذلك you can ignore, تجاهلها. If it is given, you have to use this one. And both they are the same. Let me show you something. A person with a skin temperature 33 degrees Celsius is in a room temperature of 24. Okay? So we have here, we have T and we have T naught. Because this is the person, skin temperature, and this is the surrounding. What is the net rate of heat transfer by radiation if the typical value of the skin's surface area is, this is my A, and E is given, and of course sigma is also given. This will be given the formula sheet, as we said. Meter square K to the power 4. So what is left?
Rate of
Everything. We have a Q over delta T, E sigma A, T to the power 4 minus T naught to the power 4. But there's something you should memorize it.
Kelvin.
All the temperature in, yes, and Kelvin, not. So you have to add 273 here plus 273. Please, ya shabab, don't say they are the same. No. If you say 20 degrees Celsius to the power 4, it's different than 300 degrees Celsius to the power 4. Please, in the previous one, ya shabab, كنت تستخدموا this one. It's may sometimes they equal. ليش؟ أعطيكم فكرة. If you say, for example, 40 degree minus 20, it will be 20. Okay, you can say 330 minus 290 or 310, it will be 20. I agree. But in this case, no, it's impossible to be equal. So that's my advice to all of you. Always you make that conversion. لازم تعمل التحويل يا شباب. لا تحاول تغلط هذا الغلط. Okay? حرام عليكم. We predict this one. راح نتوقع هذا الشيء منك. راح نحط لك الجواب انك انت مش محول. فانتبهوا لهذا الشيء. Okay? واضحة بارك الله فيكم. Okay, let's go to the next. I will discuss these questions quickly with you because we need to go to the waves today. I want to say something about, we are one lecture ahead from the other groups, Shabab. And this is very good for us. Why? Before the exam, I'm going to make a revision session for all my groups. So this will be easier. No one will ask why you are making some revision. In this class, I'm going to make, before 1 week, for your exam, I'm going to make the revision, inshallah, for all of you. So, alhamdulillah, we are moving smoothly and very good. Okay. On a cold day, you have to answer this question. A piece of metal feels much colder to the touch than a piece of wood. This is due to difference in their, yes?
Thermal conductivity.
Barakallah. Now, what is the comparison, Muhammad, between what and what?
Wood and metal.
And metal, right? So, they are both solids, okay? Since they are solids, I'm going to say something. We don't care about emissivity, because emissivity, we say it's radiation. In temperature, they are exposed to the same temperature, same climate. In density, we know that density of metal, we are not concerned about density. They are different. So what is left? You can simply exclude some, we can say weird answers. Just like you can skip 2 or even more. طيب. Now, a wall, pay attention, this is a very important question. A wall built from solid uniform material is in a steady state heat flow. If you double its thickness, the rate of heat loss for a given temperature difference across the thickness will become 1/2 of its original value. Double become, you think of it. I will write for you something. Think, and then we have the formula, ya shabab. We know that Q over delta T is equal to K, A over L. Is it double? So if you say A, you have to justify it. If you say B, you have to justify it. Go ahead, guys, it's easy. This is what I'm talking. Why I explained this at the beginning? You should be able to read the formula. معكم ساكتين يلا ما في شيء. It will also double. Why يا محمد؟
لأنه الكيوز تناسب طرديا مع الاريا. وهو لما يزيد الثيكنس راح يزيد الاريا.
طيب. Okay. This is one open. What do you think يا شباب? You have any other point of view? طيب. راح احكي حاجة. انتبهوا معي بارك الله فيكم. Why don't you محمد draw it? You have a wall, right? خلونا نرسمها انا وياكم. تعالوا معي يا شباب. This is my wall. مو عشان يا شباب احيانا مش بكون شكله زي كده؟ محمد الاريا this is length صح؟ times width الطول في العرض. الثيكنس اللي هي هذه الثيكنس صح بارك الله فيكم يا شباب؟ صح. For heat, it will pass through not the whole area. It depends on area, but here because if we double the thickness in this case it's L. هذه المسافة الطول اللي راح يتحرك الحرارة يا شباب من outside the wall to the inside. هو ما راح I know the whole area, but he say we double from here what? Precisely. احنا عملنا بدل ما يكون نفس الاريا بس عملنا هذا double. We do this in the walls always. احنا يا شباب دائما.
تقلل النص.
طبعا that case. So we know that Q over delta T is inverse proportion to what? So the answer will be 1/2. By the way, Shabab, we explained this last week. We say, I told you in Jordan, my country, for example, we put one wall, we keep some space, and we put another wall. Sometimes that thicker walls provide what we call by the proper insulation of heat. توفر من العزل الحراري اللي احنا طالبينه. صح؟ This is. So please, if you measure it, this is not the area. This is the thickness here represents the length. إن شاء الله واضحة لكم يا شباب. Okay. So the answer will be. Because this is easy, I'm gonna start now with the waves. Try to finish. Shabab, the process in which heat flows by mass movement of molecules from one place to another place is called by convection. Right. When the particles they are moved, mass movement, we know that they have different densities, but it is here convection by mass movement of molecules. The molecules of water, hot water, they will rise up. The molecules of cold water, they will sink down. This is the idea. So this is another, we can say, rephrasing. هاي صياغة جديدة لكم يا شباب. The mass movement here, you can say the mass movement, I will see due to here difference in density, right? How they move? Because they have different densities. We talk about the air conditions. It's kept up closer to the roof. Why, Ashraf? To the ceiling? Because it's cold. The cold, it will automatically move downward. Heater, we keep it to the down. Because it's hot, less dense, it will move up. No one will push it. No one is going to push that. Okay, Barbara. Of course, now this is also a good question. Maybe this is the last question that we have it. Shabab, an object having a fixed emissivity of
إيه.
E. Radiates heat at a rate of 10 watt when it is at an absolute temperature T. If its temperature is double to 2T, at what rate will be here, will it now radiate? The options. Who can answer this question for me? We explain it. يلا يا شباب. تفضل.
160
صح. Can you explain why?
20 صاب 16 10
الله يبارك فيك. صح 100%. You remember يا شباب احنا قلنا Q over delta T يساوي E sigma A what T to the power 4 صح؟ ترى يا شباب كل هذا we keep it constant. ركز معي بارك الله. What if we double لا تهتموا بهاي الصيغة. It's already constant for the material. We know that always the water has a density of 1000. We don't care about it. Here, this is something characterized. So what we do, if this is becomes 2T, I told you, to make it this is balanced, just like the equation, Yeshua, to make this balanced, this should be times by what? 16. Okay, this is already given, how much is it? So 16 times 10 would be 160. It will be 160, that is, okay? This is the answer, Yeshua, for you. طيب الله يعطيك العافية. This is sometimes about the imaging. Here, this is the summary. I'm gonna, as usual, Ishwa, we have a problems, and I'm gonna say something before we proceed. Allah ya Shabab, I'm gonna put some question from the problems. Precisely. Allah ya عليكم يا شباب. You have to go through the problems. لا تغلطوا تعتمدوا على إنه بس فقط. لاحظين إنه النوتس الموجودة في البرزنتيشن ما هي كاملة. صح؟ We just give you an idea. You have to go through the book, through the textbook, solve the problems. And if you can write everything, it's up to you. لكن احنا بدنا اياكم ان شاء الله تعالى you have to cover this problem. Okay, you have any question about this? Is there anything? Can we continue now to the waves?
Yes.
Right. As usual, this is something predictable. Who can tell me, Ishbab, what we mean by wave? This word. Oh, it's one type of them, Muhammad. I need a wave. What we mean by wave? When we say we know that there is a light waves, sound waves, we have water waves, waves in strings, wave in, for example, in ropes, في الحبال يا شباب, a lot of things waves, right? Now, the word wave represents what simply?
Movement of molecules.
Okay, good.
Or energy.
Let us now stick with that one. You have something more?
Yes. إنها هي تتكون من قمة وقاع.
Okay, this is a part of it. Muhammad, he actually gave us something good. We need to drive you in that direction. نعم، تفضل.
large amount.
It's
Large amount.
what they mean large amount.
Something. For example, when it's large amount of smoking
It's actually, it's contained molecules. You mean that large amount of molecules, they are moving. Okay, طيب. See يا شباب. Just like what we say, but I need to make it something very easy. See يا شباب. Wave, first of all, is a disturbance. Disturbance, in Arabic, اضطراب يا شباب. It's a motion of molecules يا محمد. Disturbance, you have to make a disturbance. Now this disturbance, see يا شباب, is simply used to transfer energy. And I'm going to put this one between bracket, I'm sorry for the here, no matter. Let me explain this for you. انتبه بارك الله فيك. Just let me make it here.
For example, light
Yes.
don't move in matter.
For example, my sound, يا شباب, listen. When I talk, put your fingers on your vocal cords. What happens when you talk?
Vibration.
That disturbance يا محمد. vibration اللي هو ايش يا شباب؟ disturbance صح؟ Now this disturbance used to transfer energy. When I make that disturbance in my vocal cords, the sound waves travel from my mouth to your ear. See يا شباب, when it goes inside your ear, inner ear, there is a small delicate membrane which is called by eardrum. It starts vibrate. صح? That sends a signal to your brain who simply recognize the sound. Of course, this happens very quickly. انتوا يا شباب لو ما عندكم الاير درامز هاي طبلة الاذن تستطيعوا تسمعوا؟ So we have to make that move. How we make it move? Just like what? Disturbance. Now, see يا شباب, a disturbance, that disturbance used to transfer only energy. It's never transferred the matter. Maybe يا شباب, in some science fiction movies, you see someone actually who stood in a chamber and simply vanished, goes to other planet. Just like the Star Trek movies or whatever. That doesn't happen. Because the waves only يا شباب transfer what? Energy, not matter. الموجات يا شباب لا تنقل المادة, تنقل فقط الطاقة, الانرجي. Okay? So, come here. For example, if you have a spring, slinky spring like this, it doesn't work, it doesn't move. Just only if you make a disturbance to that spring, start swinging, right يا شباب? And that sends your energy to that symbol. And you know that يا شباب, here we have a lot of things, even the light. There is a nuclear disturbance, Muhammad. I'm talking about the sun. Inside the sun occurs, you know, you heard about what happened to the helium and hydrogen when they joined together, okay? And that disturbance produced this light. This light travels from the sun to the earth and carry what? The energy, right? All type of disturbance happening. So يا شباب, simple. If you drop simple a small stone in a pond of water or a swimming pool, start what? The waves spread or propagate in all directions. صح يا شباب؟ لما تلقي حجر في بركة أو في هذا بتصير الموجات تنتقل. That's what we say. طيب لو ما لقيت الحجر بتصير هذه الموجات؟ Impossible. So in this one, dropping the stone is your disturbance. Okay, barakallah fi. Simple. So again, يا شباب, wave is a kind of disturbance. That disturbance used to transfer energy and never transfer the matter. هو لا ينقل المادة أبدا يا شباب. طيب. Let's see now, this is the idea. By the way, يا شباب, this lecture is a kind of only, wallahi شباب, it's a kind of revision for you. Nothing more. Nothing given here for you, something we can say hard. Okay. Now, let's start with the first. طبعا this is not working. I try to make it work. So, keep it. Now, pay attention to me. I'll make this work inshallah next month. We have the waves, we described, or we drew the waves in the form of like that. You saw this in the oscilloscope experiment. صح يا شباب? Now, in the waves, we have a certain point, you should know it. That's why we assume that already you know. We call this point crest. انتوا خدتوها اسمها قمة. صح? And this point, trough, اللي هو قاع. Okay? What we call now this distance from here to here يا شباب. Or from here to here. يلا بارك الله فيك.
Frequency.
It's called?
Frequency.
No. In English, it's called يا شباب amplitude. Amplitude. I know that. Maybe sometimes translation is a problem. اتساع الموجة أو سعة الموجة يا شباب. You heard about this one. Okay? طيب. See يا شباب. The distance from one trough to another trough, this whole distance is called by lambda. It stands for the wavelength. You know that. تعالوا معي الآن. أنتوا بتعرفوا هذه الأشياء. عندنا amplitude. The maximum value of displacement. طبعا maximum value هي كم هنا شباب؟ This is equilibrium عند الزيرو. كم أعلى حاجة؟ عند الكم؟ عند الفور صح؟ It's 4 units. Up and 4 units down. The wavelength الويف لينث قولوا لي كم مقداره يا شباب؟
20.
From 10 to 30 صح؟ إذا كم هو؟ So it is 20. I will say something more. في عندنا before of that see يا شباب. In the wavelength that means is the length of one wave regardless from where you start. I want to say something. انتبهوا بارك الله فيكم. يا شباب if you start from here from this point to complete one, this is the crest. This is one wave. From here to here, this is another wave. So from here to here, you can say this is lambda, right, Ishba, and this is lambda. So from all of it, how many lambda? Okay. Someone else said, no, I want to start from the following point. I want to start from here, from the zero. It is up to here? No.
No.
It is where? Up to? Right, ya shabab? This is another wave. You just counted. This is, by the way, 5, 10, 15, 20, 25. How much is it also? 20, the same. Someone else said, no, I want to start from, for example, from here. He will continue to up to here. So it doesn't matter. Always the wavelength is the length of one complete cycle or one complete wave. طيب يا شباب. Now we have something else. We have the wavelength and we have also the period. In Arabic we call the period اللي هو الزمن الدوري. ترى غلط نقول الزمن الدوري. يعني أو عفوا هو مش غلط عفوا هو الزمن الموجي. لما أقول طول موجي يعني احنا نعرف فيه يا شباب طول موجة. طب قول كمان الزمن الموجي. زمن ايش؟ موجة صح؟ الزمن الدوري المقصود فيها زمن دورة كاملة. Which is, by the way, here, the same thing. طيب يا شباب تعالوا معي. This is now given in times. How much the period? يلا بارك الله فيك. From here to here, how much the period? 5. You can take from anything that you have. This is, since you know it's time for one complete. See يا شباب, this is time for one cycle, or one wave, or one vibration, or one oscillation, all of them. When you say, for example, wavelength, lambda, is simply, is distance, we say, distance of one cycle, again. Now, we have something more. We have something called frequency. This is the last term, Shabbat. Frequency is it's a concept that relates number of waves or cycles or oscillation with the total time. That's why I need to say something. Frequency here is given as follows. We studied this, by the way. Number of cycles, عدد دورات, over time. Okay? Number of cycles over time. If we have in Muhammad one cycle, يعني موجة واحدة, what will be the time? Will be the period. Time for one cycle, صح يا شباب? So if we here number cycle, then one, this will be what? T. وانتوا درستوا يا شباب frequency is equal to 1 over capital T, صح؟ درستوها صح؟ This is what we have. إذا احنا هنا يا شباب frequency F is equal to 1 over T. طب T already 5. So 1 over 5, which is 0.2. And you know that frequency measured in hertz. All this, I think, you studied, right? طيب. Before we go ahead, you have any problem with these? These basics, يا شباب, ديروا بالكم. طيب. Just 5 minutes, then I will stop. تيبوا بركة. Now, in front of you, Shabbat, we have just like the disturbance we occur. If we drop a stone in water, swimming pool, ponds, whatever is it, the waves will simply propagate in all directions, not in only one direction. As you know that. Propagate to the right, to left, to the up, down, everywhere. Now, to describe this here, Shabbat, we create or invent something called by the wave model. Wave model describes the basic properties of waves and emphasizes here those aspects of wave behavior common to all waves. Wave model describes the behavior of the waves, how they are moving. By the way, did you know someone say that the waves they have crest and troughs? Yes, but not all the waves they have crest and troughs. Part of the waves. Because other waves they have compressions and rarefactions. تضاغط وتخلخل. صح يا شباب؟ مش كل الموجات تعملها مثلا قمة وقاع. انتبهتوا عليه برضه؟ Not all the wave يا محمد here travels in medium. في عندنا waves لا تنتقل إلا في الأوساط. Just like the sound. The electromagnetic can travel in vacuum. See what is the difference? Sound can travel in vacuum يا شباب؟ لو ما في هواء بينه وبينكم تسمعوني؟
لا.
That's why always the astronaut, even they step beside each other, they are talking by radios. رواد الفضاء بيتكلموا باللاسلكي مع بعض وهم جنب بعض. There is no matter between them. So there is no, we can say medium, transfer that energy to each other. Okay, traveling wave is an organized disturbance traveling at a well-defined wave speed. Now, a wave disturbance is created by a source. Someone, just like me now, I'm the source of the wave disturbance for my sound. You are also doing the same. Now, a wave transfers energy, but there's no material or substance transfer, as we mentioned, Teshaba. This is normal here. So, I want to say something also. In this wave model, we try to make something common for all the waves. We know, for example, I'm going to show you something here. You studied that speed of the wave, Teshaba, equals F times lambda. You heard about this formula, right? Did you know that this formula you can apply for all types of waves? This is the wave model. You make something common between them. أقول لكم حاجة. في الإلكترومagnetic أحيانا بيستخدموا بدل V هنا بيستخدموا C. اللي هي سرعة الضوء 3 times 10 to the power 8. But it is the same question, the same formula. صح يا شباب؟ وأتوقع أنتم استخدمتوا هذا كثير, a lot, في الwaves. So this is actually the idea of the wave model. طيب. Just, yes, I will here, if you just allow me. Now we're talking about mechanical waves. The waves, I'm going to say, either mechanical waves, I'm going to say, or electromagnetic waves. Okay, barakallah fikum. Ya shabab, it's easy. And mechanical waves requires a medium to travel through. تحتاج إلى وسط لتنتقل خلاله. Just like the sound. صح يا شباب? So, easily, I'm going to say requires medium to travel through. Now, in the second one, in the electromagnetic, we can say can travel in vacuum. And in medium also. Ya shabab, electromagnetic can travel in vacuum and medium, both. Did you know the light passing through the glass? Right, ya shabab? Glass is a medium. The light passing through the water, which is also medium, right? So this is the idea. Now, apart mechanical wave, just like the sound, and electromagnetic wave, just like light. This is all of, I think this is the basics. So, mechanical waves are waves that involve the motion of the substance, such as water waves, travels in water, sound waves, waves on a string, اللي هو الحبل يا شباب أو الخيط, a lot of things. طيب. Now I need to say something. When you talk about the strings and chords, we mainly concern about the musical instruments. يا شباب الأدوات الموسيقية. We have a string, sometimes called a chord, اللي هو الوتر يا شباب. We simply stretch that chord between 2 points and we just بالكرومت احنا بنعزف عليه. Now the vibration of that chord make the sound, right? انتبهوا بارجو. In every here musical instrument we have many chords. And these chords, each of them has its own particular tune. يعني هو كل واحد له نغمة الخاصة فيه، صح؟
صح.
And who's playing with that, he just simply shifts his finger from one to other to create that whole music. أنا معلش معلومات الضحلة فيها لكن the idea is what يا شباب؟ If the chord is not stretched, you cannot play it. صح؟ ولهذا السبب تلاحظوا في العود أو الجيتار في مسامير في الآخر، صح؟ تشدوا.
تشدوا تخفوا.
طبعا ما تشدوا إن قوة تشد للآخر، لكن تشدوا لدرجة معينة. One more point. Also بارك الله فيكم. The material that the chord made of is different from one device to another. تعرفوا يا شباب إنه أوتار الجيتار مصنوعة معظمها من معدن. هذا المجنن اللي بصير تشوفوا الأجانب هم. هو بتلاقيه يضرب في الجيتار وهذا هو مصنوع من معدن. لو سألتكم هذا السؤال، أوتار العود العربي مصنوع من إيش؟
خيوط زي الخيوط يمكن.
بس خيوط إيش؟ ما بتعرفوا هاي المعلومات يا شباب.
حرير.
طيب يا شباب. They made of cat guts. أمعاء القطط. لا تقرفوا من هالشيء هذا. أول ما استخدم هذا أمعاء القطط أمعاء الحيوانات هو العرب في عملية أنتم في الطب يا شباب في عملية خياطة الجروح. إن هذه المواد تذوب في الجسم ولا تؤثر عليه. لكن وجدوا يا شباب الطبل مثلا مصنوع من جلود الأبقار، صح؟ This is natural. مثلا العود يا شباب هو it's a Arabian عود، يعني هذا جهاز عربي. يعني ما بيعزفوه في الأجانب. لكن هو مصنوع من المواد موجودة في البيئة الموجودة فيها. صح؟ تجد معلش يا شباب روح على بلدان أخرى تجد أوتار مصنوعة من مواد ثانية. لهذا السبب لاحظ بارك الله فيك. كل مادة every substance has its own tune. يعني عندها نغمة. يعني أنت لما تضرب بالقلم هذا الآن على الطاولة غير تضرب بالمساحة. هنا غير تضرب بالمساحة. صح؟ لاحظ الصوت وهنا الصوت. طبعا تعرفوا احيانا في البيت كنت تشوف كنت تنظر غدا تمسك الشوك وتصير تطقطق، صح؟ احيانا يعني بتصير معنا دائما عشان تتسلى تقول والله بنتظر الغداء. This is the natural. صح يا شباب؟ Sometimes every device has its own tone. عندهم نغماتهم الخاصة. Let me talk about. تعالوا معي أنا بس نتكلم عن حاجة بسيطة then we start. شوف يا شباب. The speed of the string, the speed of sound in a string depends on tension, قوة الشد, directly, and depends on what we call by the mass density. على هي يا شباب mass density that means the mass per unit length of the chord. اللي هو يا شباب الكتلة لوحدة الطول. This is called mass density. هنا يا شباب this is string tension, قوة الشد في الخيط. This is string mass divided by length. يعني كم طول المتر من هذا الوتر؟ كم طول المتر؟ كم كتلة؟ وكم طبعا في أوتار. تعرف يا شباب مثل البيانو عندهم أوتاره سميكة. بيانو ضخم، صح؟ في عندكم يا شباب أجهزة اللي هو الكمان الفيولين هذه أوتاره مختلفة. في جهاز زي الكمان بس واقف واحد فيه. صوته مزعج هذا. برضه كمان، صح؟ different chords هذا اللي بنتكلم عنه. طبعا في اشياء كثيره يا شباب هو في حتى انا يعني بعرف الاشياء العربيه. تعرفوا انتم يا شباب اللي هو اسمه القانون هذا القانون فعلا رائع جدا هذا العربي. يعني هو بتلاقي كانه بدور على حاجه لكن هو بيعرف. صح؟ بس natural. احنا we're not talking about بالمناسبه يا شباب to link this with you. اذا صرت ان شاء الله you are specialized in hearing راح تعطي مريضك to explore his ability of audible ability. راح تعطيه انت musical tones. راح تعطيه انت بعض النغمات لها ترددات معينه وتشوفه هل بيسمعها ولا لا. ترى بالمناسبه شباب زي ما في قصر في النظر احيانا بعض الناس ما بتشوف بعض الالوان، في بعض الناس ما تسمع اصوات معينه. انتبهتوا علي يا شباب؟ وهاي وظيفتك انك ايش تعمل له؟ اللي هو الاكسبلور. طيب راح اتوقف هنا الله يعطيكم العافيه. ان شاء الله نكمل يا شباب ونكمل. Don't forget your assignments الله يرضى عليكم this week.
دكتور معي الأسامة، أسلمك إياه؟
اللي معه مسلمني اياه هاتوا يا شباب.